Hello everyone, I am Rahul. Today I am here to explain the end-to-end data engineering project which has been developed by me and my teammate Pradiksha. So, without any delay, we can head into the problem statement. Okay, the project which we are dealing is about Walmart. We all know about Walmart. So, to the persons who don't know, so Walmart is the world's largest company by revenue and the world's largest private employer. And Walmart also sells a wide range of products, including groceries, health, and wellness products too. So our project is about Walmart, and Walmart is facing some various problems in various scenarios. To be specific, the first one is about inventory management. What is inventory management? Inventory management is nothing, but it is just ensuring optimal stock levels are essential to meet the demand without incurring excessive holding cost of stockouts. That is inventory management. Coming to the second, which is revenue forecasting, it is nothing but it is the accurate sales forecast that enables the company's plan and its revenue and the budget accordingly. And the next is investment decisions. So it is nothing but so based on the predicted future sales, so we must be informed our investors and take investment decisions accordingly. That is what the investment decision is. And coming to the last point, which is stock price and investor perception. So it is meeting or exceeding sales targets, which can positively impact stock prices and investor confidence. While it is underperforming, it can also have negative consequences. Okay, so this is our problem statement, and we are going to provide solution for this problem statement using our data engineering. Okay, so we are going to build an end-to-end modern data engineering architecture solution for this, which we are going to discuss in the next slide. So this is the data set we are gonna work with, and it contains four different files. Heading into the first one, which is nothing but store CSV, which has 45 stores and has two columns such as store types and store size. And the next one is train.csv, which contains the historical sales data from the financial year 2010 to 2012, and it holds 4,21,570 rows and has 5 columns, which is store, department, date, weekly sales, and is holiday, which is a column which will have a boolean value which is true or false, which says whether it is on a holiday or not. Okay, so if you notice the number of rows, it is around 4 lakhs. Yeah, we really gonna work with huge amount of data. Okay, coming to the test CSV is the one which is going to help the machine learning predictions. So for example, we're gonna predict the weekly sales data and the available stocks with us. Okay, in that the straight test.csv will be more helpful in predicting those things. Okay, it is similar to train CSV, but it will have minimal number of rows, minimal number of columns such as store, department, date, is holiday. Okay, and it also holds around 1 lakh entries. Coming to the last file, which is feature.csv, which has 8,000 records. Okay, and it has 8 columns such as store, date, temperature, fuel price, markdown, CPI, and unemployment, and is holiday. So this is the data we really gonna work with. Okay, now this is our solution architecture. Okay, so if you notice here we have the source data. So our data set is located in a Azure SQL database. Okay, from there we are going to fetch the data through data factory. Okay, we're gonna build some pipeline, some dynamic pipeline which will fetch all the tables from our SQL database and will ingest into our Azure ADLS Gen 2, so which is nothing but Azure Data Lake Gen 2 storage. Okay, and for this project, we have used the medallion architecture, which is nothing but, so medallion architecture is nothing but it is a process or it is a process where we follow some layering concept, so which will have three layers: bronze, silver, and gold layer. So bronze layer data is the raw unstructured data, and the silver data is more cleaned and normalized data, and the gold layer data is used for reporting and serving purposes. It is a high profile data. Okay, this is the architecture we gonna use for this project. So from data factory we gonna ingest the data into our ADLS Gen 2, and that and from that layer, from that bronze layer, we gonna fetch the data, and using Azure Databricks we gonna transform the data, and where we perform some various transformations such as cleaning, handling null values, data profiling, and data enrichment activities. And once the activities are performed, we are saving it is in a format called Delta Lake, which is a more optimized format which is used in big data. Okay, in big data industries, Delta Lake is the format which is used to save the silver layer or gold layer data. The benefit of it is by saving in a data Delta Lake is it is a more optimized storage, and it has many features such as versioning and time travel features we can perform on top of it. Okay, so once the data is cleaned and enriched, it is loaded into the silver layer. And next, so then next is the coming the gold layer. So in gold layer we perform some business level aggregations and calculations. For to be specifics, we gonna use machine learning models to predict the weekly sales and the stock which is available with us, and those predictions are done in Delta Lake. And once the predictions are done, so we gonna load it as a delta table, which is a feature of Azure Databricks. So using that Azure data delta table, we gonna write some we're gonna build some interactive dashboard using Azure Databricks dashboard technique. Okay, through which will the reporting team can analyze and visualize the data, and more predictions can be made, and more insights can be made. And for the security purpose, we are going to use Azure Key Vaults. So where we gonna save some secrets, whether it may be our SQL Server, Azure SQL DBs, admin password, and Azure Active Directory is a thing. So let's say, so as I said, we are a team of two members. Okay, so we gonna work in a same resource group. Okay, so we need in order to do that, Azure Active Directory is a thing where we can create a group. Okay, in that group I can assign my another team member who is Pradiksha, and give her access to my resource group. By using my resource group, we both can work on a single resource group, and it can be a more collaborative project. So instead of working on a two different resource groups, we can work on a single resource group. Okay, that is the use of Azure Active Directory. And for this project, for we need to continuously integrate and deploy. So we have created a CI/CD pipeline through Azure DevOps, which will continuously integrate and deploy the our project. So for example, so when we make any changes to our Azure Databricks notebooks, and that change will be there reflected in our main branch, and from main branch it will be reflected into our release folder, and from a release folder our main ADF Azure Data Factory pipeline will make the changes. And this is how we implement continuous integration and deployment in our project, and we're gonna see one by one in detail. Okay, so basically this is our Microsoft Azure default homepage. As I said, our dataset is located in the Azure SQL DB. I will show you that. Okay. So basically it is our database. This is our database where you'll have multiple options. You can use query editors where you can do query as you do in your MySQL or SSMS. So let me log in first. So once you log in, your query editor will open. So where you can find the tables which you have. So as I said, we have features table, stores table, test table, train table. Wait. So at first, while we are discussing about dataset, I said it is a CSV file. Okay. So then you will have a doubt how I converted this CSV file into the database and converted into specific tables, right? So I will tell you that. So I did this by using SSMS, which is nothing but SQL Server Management Studio, which is like MySQL, or it is for Microsoft. Okay, so where you need to create some, first of all you need to create some database. So how can you do that? We all know we can do that by creating using query. So we can use create database, your database name, and once you created the database, right click that database and go to task, and you will find the option called import flat file. Click on it, and once you click this you will see a pop-up saying so we need to specify the input file. Okay, so you click next. So my SMS is taking long time. My system is slow. It has a very much less amount of RAM. Okay. See, once you click next. So we need to browse the files. We need to click the say the location where our CSV file is located. Okay. Once you say that, so let's say here write as train. Okay, open, and so we can specify the table name, and if you need a schema, so it's a schema name, we can give the schema name. So it is saying already exists because I have already done. So this is the way you can create a table for each file. Okay. Oh, okay. Then how you will I'll have another doubt. How I imported this database to my Azure, exported this database to my Azure SQL DB, right? The thing how I did means again right click the database, go to task, and you will find the option called export data tier application. Click that. Once you click this, so you will find a pop-up and click next. So there will be two options where you can save the. So what it will do is it will create a backpack file for our database, and using this backpack file we can create a database. Okay, I'll tell you that. So first, to save that backpack file, we can save in two ways. One, we can save to our local computer, or we can directly save to our Microsoft Azure. For that, we need to provide our credentials. Once we provide our credentials and container path, we can directly save in that. How I did means I saved it to my local desktop, and from local desktop I uploaded it to my Azure container, or you can directly upload. It is our choice. Okay, so from there I will tell you how I imported those backpack file to the Azure SQL DB. Okay, coming back to our Azure portal. So yeah, so how to import that? So go into your SQL server. So once you are uploaded your Blackpack file to your storage account, okay, go inside your SQL server. In that, there you will find the option called import database. Click that. If you click that, if you provide subscription details, and we need to select backpack. So this is the thing where we need to select where our backup file is located. Okay, so from this we need to select. So let's say my backpack file is in C. I have a folder called backup, and in that I have my backpack file. Okay, we need to select this. Okay, this is the backpack, and we need to select the compute option. So mostly we use for our purpose standard series is enough, and we need to enter the database name which we need to give, and we need to provide our SQL credentials. If you do this and click OK, your database will be created in the Azure SQL DB. Okay, this is how I did This is how I took my SQL Server local data into Azure SQL Cloud, Azure Cloud DB. Okay. Okay, now we have our data in our Cloud DB. Okay, what is our first step? Our first step is data ingestion. So we're gonna fetch all our tables from our Walmart database, which is located in our Azure SQL Cloud DB, and load it in our bronze container in our storage account, which is ADLS Gen 2. Okay, how we gonna do this? We gonna use the help of data factory. What is data factory? Data factory is nothing but it is a Azure service which is helps to orchestrate data movement. Okay, so here we can create multiple, so here we can do multiple things. Here you can create pipelines. So here we have option called manage, where you can create a linked service. So what is linked service? So linked service is nothing but a connection. So okay, so I'll tell you in the detail. Okay, we have linked service. So we have multiple things here. We can use triggers. We can set triggers which will say what time our pipeline should run. And also in this we can create multiple things. We can create our data set. Okay, so first we're gonna create data set. How we are gonna create pipeline? Okay, so how we gonna create pipeline? So we can do this by clicking your new pipeline. So once you do this, see, this is the default window. It will appear. You can name the pipeline according to you, and it will have some activities where where you can do different things. So do for us, we need a copy activity. Okay, so this copy activity will fetch all data from all tables from Azure SQL DB, and we need to load it in our ADLS Gen 2. So here you can see there is a option called source. So where you need to specify. So specify what is your type of data set. Okay. So what is our type of data set? Where is our data set located? As I said, as our data set is located in Azure SQL DB, right? So we need to select that. So once I selected that, so here you can name your data set accordingly. We need to create linked service. As I discussed before, linked service is nothing. See, linked service is a thing. So first we said where is what type of data we have and where it is located. Okay, our data is located in Azure SQL DB. So once we say that, we need to say to Azure. So how can I connect to that Azure SQL DB? So linked service is a connection. So we specify, and Azure will use that and make a connection to our DB. Okay, so we need to create a linked service. Okay, how we gonna do that? So if you click that, there will be some here we can select your subscription. Once you do that, you need to enter your Azure server name, SQL server name. And so if you enter that, you will your databases which you have in that server will display here. And you need to specify your authentication type. It may be Microsoft enter ID or SQL authentication. And key vault is a thing where you can store. You can, instead of directly giving your password, you can store your secrets there and use that secrets here. Okay, you can do it multiple way. This is how we create a linked service. Okay, this is our source. Okay, now we are told Azure where is our data. And now what we gonna do is we're gonna tell where we need to store this data. Okay, that is sink. So we need to create a sink. So what is where is our sink located? So which is ADLS Gen 2. Here this is our sink. Okay, so what type of file we need? I need a CSV data. So for CSV you need to select delimited text. Okay, click continue. And heading into the linked service, yeah, so we told our data set it will be located in ADLS Gen 2, and we need to say how we are going to connect to the ADLS Gen 2. If you do this, and same thing you need to do, you need to give your storage account name. And if you do that, you can connect, you can test connection here. And your linked service will be connected. And once you do this, here there will be option to display the folders. Okay, and you can select which folder you need to do. And I will show you the details things, okay, in a detailed way. And okay, how we gonna do? So we gonna create multiple copy activities for each table? No, we're gonna create a dynamic pipeline which will fetch each table. So we're gonna run only one copy activity, and that one copy activity will fetch each table and create a multiple files with the dynamic folder structure. Okay, I will show you my pipeline. So Okay, so this is our end-to-end, complete end-to-end pipeline for our Walmart project. So don't worry about these things. I will explain you one by one in detail. Coming to the first thing. So as I said, so we need to dynamically fetch each table from our SQL Cloud SQL DB, and so to do that, in order to do that, we use the lookup activity. So what is lookup activity? Lookup activity will, so if we need to specify what data set which we need. So if we do that, lookup activity will return the data set which we specified. Okay. So which, if you look into this, so if you look into this, so it will be, so generally it will be this, where you can, here you can name your lookup activity. Once you go into the settings, so this is the place you need to specify the data set. Okay, where is our data set? As I said before, we need to give the type of source of data set. So this is the linked service to connect to our data set. So coming to this, and we need to give what we need from this data set. Okay, so we need we can, if you select table, you can select whichever table you want, but what we need is entire table, right? So in order to do that, we return a SQL query which will return all the tables inside the cloud DB. Okay, so I will first of all, so here you have an option to preview the data. So if you use this, you will get a preview. And so yeah, so you need to unenable the first row as a column, because we are going to return multiple tables, right? So I will show you the output of this lookup activity, so how it will look like. Okay, so to showcase you, I have ran the pipeline, and I have the output of lookup activity. As I said, you can see, so it returns the every table name inside our Cloud DB. If you notice, we have train table, test table, stores table, features table, and we are going to use this table name. And by using this, we're going to run we are going to run for each loop, where we will specify dynamically the table name, and we will do copy activity accordingly. I will show you that. Okay, so we have a activity called for each table. So for each activity, will it is similar to our for loop in our Python and programming language. It is similar to that for loop. It is same like that. So here you can name this for loop activity. If you go to settings, if you see here, what I have done is, so this is the data factory expression builder, where you can dynamically give the value. And if you notice, I have given, so lookup for Walmart tables. If you remember, this is our lookup activity. From there, I am getting the value, which is value is nothing but the table name. I have shown you, right? I have shown you the output of lookup activity. From that, I am taking only the value. So value is nothing but the table name. Okay, I am using that. And for loop, we are going to run this for loop sequentially by order. Okay, and what I going to do, so I'm going to do a copy activity. So inside this, you can, inside for loop, we are going to run a copy activity. Okay, so in this copy activity, so here you can name your copy activity. If I go to source, we need to specify the source of our dataset. Where is our dataset? You all know, our dataset is in SQL, Azure SQL Cloud DB, right? And we again, from here, we are not going to specify the table. What we going to instead we are going to dynamically pass the table name. So table name where we are getting, so table name we are getting from the lookup activity. Lookup activity, we are passing inside for loop, for each loop, and for each loop, for inside for each loop we are doing a copy activity and getting the table name. This is how we pass. So this is our source data set. Okay, coming to the sink, where we need to store our data. We need to store our data in ADLS gen 2, right? So in ADLS gen 2 I don't need to store as it is. I need a folder structure. I need a dynamic folder structure. Okay, so for example, so in our bronze layer I need a folder called table, and inside that folder I need to have different folders which will have each folder name dynamically. So for example, features table CSV should be inside the features folder. Okay, so I need in such a way how we can create that folder structure. So again, by dynamically passing the table name. Okay, from that I'm getting the, so we all know, so we are getting the table name from lookup activity, right? And so by using that lookup activity, what I'm doing is, if I open this sync data, here you can see I gave an expression such as which will create a folder called tables. Okay, so I need as I said, I need a folder direct structure called tables, and inside this I need to have a each folder for each table, right? So first of all, in this bronze container I need a folder called tables. Okay, in this table what I need is what will be my file structure is, so I inside this I need a file called, I need a folder called dot table name, and my file name should be table name dot csv. Okay, so this is how I am giving the dynamic folder structure. Okay, again here you can test connections, you can edit it, you can do multiple things, you can preview your data. Okay, so your preview will not work here because it is we are running, we are not giving the direct path, we are giving the dynamic thing. Okay, this is how we ingest the data, in our pipeline. Okay, so how to run this? So once you created this pipeline, you need to validate it. So validate it will it will, if there is any errors, it will show here. So we have no errors, it says our pipeline has been validated. Okay, so there is a two things to run. You can run in two ways. So one is using debug will instantly run our pipeline. Okay, to instantly run our pipeline we can use debug. But what is trigger? So trigger is a thing, so we can schedule your pipeline run, so you can schedule accordingly. So let's say you need your pipeline to run in a particular time. Let's say you need for each day you need to run at least one time your pipeline. You can schedule it accordingly. How we can do this? If I show you, so here you can choose triggers, you can create a new trigger. So here you can specify the start date when your trigger must start, and you can specify the time don't reoccurrence is how much time you need to occur. So now it is in minutes. You can set this to days, weeks, months also we can set, which is, so for particular day one time, for a day one time, for a month one time, like this you can specify. And also we can specify an end date. And yeah, so it shows trigger. If you click trigger on a creation, so once you create this trigger, first time will be pipeline will be starting. So this is how we create a trigger. Okay, so before all doing this, there is an option called publish is saving your work. So once you did this, is once you click debug. So first of all, what you need to do? So you need to validate, you need to click debug. If your pipeline is successful, you need to publish it first before setting a trigger. Publish it. It is like saving your work. Okay, it will save your work, it will save all our tables. Okay, so whenever you come again, there will be your pipeline, you can use it. Okay, and once you publish, you can set your trigger accordingly. This is how you work with pipelines. Okay, pipelines and how to run pipeline. Okay, so now I will see my bronze layer. So I have already run my pipeline, and now we can go into my storage account, and we can see our how it is, how our file is located. Okay, so this is my storage account. Basically it is, as I said, it is ADLS gen 2. So there are two types of storage in Azure. One is data lake storage, and another one is blob service. The only difference, main key difference, what I found out between blob service and data lake storage is, in blob service you can't create directories inside a container. It is hard to create, you need to code it using Databricks. But in data lake storage there is there is the option to create directories inside it, which I find it more user friendly. Okay, I will show you. So if you go to inside, so we need to go inside container, you must click this. So this is my containers which is available. As I said, we are using medallion architecture. I have bronze, gold, silver layer. I stored my data in bronze. Okay, if you see here, there is a folder called table created, and as you said, you the benefit of ADLS Gen 2 is you can create folders inside containers, right? So here you can see you can have directories is nothing but folders. Okay, this is the use. See here you can see the tables folder. Means if I go inside the tables folder, see there is dynamically each folder is created. How it is done? We gave it is done using lookup activity, right? From lookup activity, pass the table name dynamically, and each dynamic folder is created according to the table name. And inside this, my file is also created with the file name .csv extension as we specified. Okay, this is how this is how we do the ingestion process. So first step is finished. Okay, our data ingestion process is finished. Okay, now we have finished our data ingestion process. Okay, this is the first step. Now, if you remember, our next step is data transformation. As we discussed earlier in our solution activity, solution architecture, we are going to use Databricks, Azure Databricks for transformation. Okay, so if you click Azure Databricks, you can create your workspace. Okay, I have already created my workspace, and inside this, if you it is the default page. It will look, so, and if you launch your workspace, it will take you into your Azure Databricks. Okay, I have already opened this. So this will be the default page, how it will be look like. Inside this, there is multiple things. Here is your workspace. We can manage all your things, and there is a thing called catalog is nothing but it is another thing called another thing which is a folder structure. And if you do go inside the compute is the main thing. So it is like a compute is like a engine. So it is the thing which will run our code. Okay, so first of all we need to create our compute. Okay, how we can do this is, so our policy, we can keep it unrestricted. We don't need multiple nodes. Single node is enough for our works. Okay, and so if you need to specify a runtime version, we can be specified. I let it be standard for me. And my node type, I can configure my node. Say there is up to 384 GB memory and 96 cores. For us, basic configuration is enough. Okay, this terminate activity is important. So it will terminate our cluster accordingly after. So let's say it is 120 minutes. It is a good practice because if we keep our cluster running, our amount charges will be increased. Okay, so this is how you create a compute. And for my thing, I have already created a compute. Okay, I'm going to use that. And coming into our project folder, so I have created a repo called I have created a folder called Walmart repo, and inside this I have my notebooks. Okay, so I have three different notebooks and one notebook for mounting. What is mounting? Okay, now as I said, we need to do transformations. And where is our data? Our data is located in ADLS Gen 2, and so we are working in Databricks. To connect our data from ADLS Gen 2 to our Databricks, we need a connection, right? We need to say how we need to connect our data. How we gonna do this is using this mounting code, and we can do this in multiple ways. I have chosen a particular way. If you if you go inside this Azure document, there will be multiple ways. I have chosen a particular way. Okay, so you can use this code. You can get this code from Microsoft page. And what is source? Source is nothing but where is our this bronze, if you remember, this bronze is our container name. I will show you that. Let me show you. If you see, bronze is our container name, and bronze is our container name. What is Walmart DS? Walmart DS is our storage account name. So you should give your container name at your storage name. Everything is same. And mount point. So mount point is the thing. It is more important. It should be unique. Okay, so it should have a default forward slash mount and forward slash, and after that you should give a name. Okay, this name should be unique. and you cannot run this again and again because one you can only create a one mount point, right? So yeah, you should give a unique mount point name. Okay, this should not be repeated. Coming to the extra configs. So if you see here, everything is same, and this thing is our storage account name, and I have given my storage account key. How can you get that? So if you go to our storage account, if you search for keys, there will be thing called access keys. So there will be different keys. By using this, if you show this and you can copy this, okay, you should need to copy this and provide here, and if you run this, you will return a statement called true. And now we have mounted our what this bronze folder, and same thing is for bronze container, and same thing is for silver container and gold container. Now if you want to see what is in a bronze container, you can use a command called dbutils.fs.ls, and we should specify the mount point path. What is our mount point path? So our mount point path is Mount Walmart Bronze. Okay, if you go inside this, let me check. So if you shift and enter, so it will run. If you see, there is two folders inside it, which is backup and tables. We can verify that. If I go to my storage container and go into my storage, bronze storage, and if you see, we have two folders. Okay, so it is displayed. This is how you can use dbutils.fs.ls and to display your things. Okay, so this is the mount code. Okay, and next we are discussing about the bronze. Okay, so bronze notebook. So in this bronze notebook, what we are going to do is, the first step what we have done is, so we have defined the file paths. So if you remember, as I said previously, so this is the path where the tables slash train slash train.csv is located. So what that it means is, it will go inside the tables folder, it will go inside the train folder, and here it's a file is located. It is the path of the file. So here we are specifying and giving a variable for each file, and we will use it accordingly. And so this is the data frame. So we are loading our CSV file into the Spark data frame by Spark data frame. So header is true. So what, because so the first row will be our header. So schema is true. So whatever the schema is in this file, so it will retain that schema. Okay, so if you give this, it will retain the schema. If you give false, if you don't give this, it will randomly assign a schema. So for example, it will for all columns there will be string, and we need to manually change all columns. Okay, so this is how we load our CSV file into our data frame. Okay, and what I did is, first step is I checked for how much rows our data have. So these are the number of columns, number of rows our data has, and I cross verified to check any rows as missed or not, and nothing was missed, everything was good. Okay, and next thing is schema. So as I said, it will retain its own schema. So I'm checking what type of schema it has. Okay, you can do this by giving your data frame name dot print schema. So it will return your schema name. If you see stores integer, data department integer, it is not problem. Date is timestamp. I think we need to convert it to the accordingly. We need to convert this timestamp data type accordingly. Okay, we need to convert it to date format, and everything is so for each file the schema is printed. We're gonna use this, and we're gonna handle the null values. First thing is I have done is drop duplicates. So you can use this inbuilt functions which will drop the duplicates from each file. Okay, so the next step I have did is handle the missing values. So if I explain each and every single line, it will make this video too lengthy. For time concern, I'm skipping out these explanations. So what I have did is, so I've handled the missing values in feature data set, and handled the missing size columns in stores dataset, and I handled the sales column in train dataset too. Okay, so next step I did this, I removed so I validated the sales data. So I basically removed the negative sales data, Okay, and I handle the outliers using Z-score, which is a feature in PySpark. So, and I have converted, as I said, so I converted the timestamp column into date format, and I have also cleaned the test data set. Okay, and casted the date column into the date. Okay, and next thing I have did is more cleaning in stores data set. I trimmed the white spaces and fixed inconsistent data types, and I handle the outliers using again Z-score, and I did features dataset cleaning. After doing all cleaning, okay, what is the next step? So once we did all cleaning, all validations, all checks, all mandatory checks, we need to write it into our silver container. Okay, what is how can we do that? Okay, I what you can do it in multiple ways. You can just write a single statement such as what let's say, okay, df dot write, let's say, what is our let's say features df dot write dot. So if you see, you can say you can have a single write statement. But what I have did is, so I have created a more dynamic statement, so which will run. So since why? Because we are going to run this notebook in our pipeline. Okay. So since for each time the pipeline runs, so it should update the files accordingly. It should not create. We must be sure should not create multiple files with the same name. Correct. So to do that, I have created a code. I have written a code which will dynamically clear the entire contents in the directory to ensure our clean overwrite. So once it is done, so it will write the each data frames accordingly. So it will do accordingly for features silver. So for features df, so there will be a folder called features here, features silver. In that it will update this folder. And what is the format we are updating? We are using delta format. As we discussed before, from silver layer our data type, our data type will be in delta. Okay, as I said, delta is more optimized, which is used in more which is used in industries. So nowadays in big data, so now I have run this already, and I will show you how this is stored in our container. Okay, so if you go inside the silver container, you can see there is features silver stores. Ignore this final silver as far as now. I will tell you. I'll tell you that later. What happened? So just a second. My session has expired. Okay, sorry, my session has expired because I'm using my organization's account. So each and for every 60 minutes my session will expire. I need to log in back. Okay, so what we're discussing is, so yeah, so if you see here, there will be a separate folder for features silver, store silver, test. Ignore this final silver as far as now. I'll tell you later. Store silver, test silver, trends. And if you go inside this, there is a folder, there is a file in I forgot you to tell you this. So in this Azure Databricks, and more in a database file system. So database file system, the this files will be located in a Parquet format. Okay, there will be a partitions. There will be partitions which the file will be divided into partitions, and you cannot directly view it. So if you have if you need to do that, if you edit it, you can download it and you can view that. And CSV file you can edit that. But yeah, so if you see this, since we saved in delta format, it has delta log, which will have some log files. So you can use this. Since I said it has a time travel feature, it will use this delta log. It will go to previous versions and we can utilize it. And for each silver, so each file, it has created some folders. And if you look into this train silver, there has been multiple partitions. The file has been divided into. It will be according to the file size, the partitions will be made. Okay, so this is our bronze notebook. Okay, next our silver notebooks. Okay, coming to our silver notebook. Okay, so we need to first load our we load our delta file into our PySpark data frame, right? So I have did this. I have loaded my PySpark data frame into each DF. So files into each PySpark data frame. Okay, and what I did is we need to I have joined all the files into a single file. Okay, so what I made is I have made I specify made a inner join. So join or inner join both are same as we all know. So I gave on condition what so I performed a left join. Okay, so on store, so which will join the train df and stores df. Okay, and I joined the train df and feature df. So it will basically this final df will have train data, features data, and stores data. Okay, understood. And for test data, what I did is I joined the stores data. Okay, so this stores data will have test data, features data, and stores data. Okay, all right. So totally we have two datas. Okay, and if you infer the schema of the train data, so this is our train data schema. Okay, it will have store date, is holiday, depth, department. So is holiday is boolean, it will have true or false. So whether it is a holiday, it will be true. If it is not, it will be false. Okay, we have these many columns. And final test df will have minimal number of columns which will don't have some features. Okay, so this is what our 2df is. Okay, so now, so once we joined the df, we are going to load this into our silver container. Okay, we have done the same way which we did in bronze container. So we load it dynamically, so each time we'll run, it will clear the it will ensure the clean overwrite is done. And this is where, so where you have stored it, this is where you have stored final silver. So inside final silver we have a folder called for test silver we have one folder, for train silver we have one folder where our delta file is located. Okay, till this we have done. Next is, as I said, as you all know, it is gold. So once I go into gold notebook, where you perform some business aggregations and calculations. So first step I have loaded this data from silver container to our PySpark data frame. I loaded this. And so for our training purposes, for our machine learning models, I have cached the columns into double. Okay, so once we did this, so once we did this, I'm using vector assembler. So vector assembler is a machine learning features, machine learning what you can say machine learning feature. It will, what it will do is it will combine all these columns and into a single column. So for a machine learning model, so it needs a single column. Okay, so what it will do is, see, so every features will be combined into single column. Okay, for and it will be grouped into some. So for each features, the weekly sales is this. Okay, for each features, the weekly sales is this. This will help the machine learning model. Okay, and we what we have done is we have implemented a regression model. So what is linear regression model? Okay, so what is linear regression? So linear regression is a machine learning algorithm which is used for predicting a continuous target variable, or let's say, so it is useful in predicting the relationship between independent variable and a not dependent variable. Okay, in independent variable and a dependent variable, sorry. Yeah, so we have used this, and what is the goal? So our goal is to reduce using linear regression. We are searching for to reduce the difference between predicted and actual values by finding the coefficients. So by finding the coefficients using method like r squares. Okay, so this is why we use linear regression. And another thing we have used is, if you see, so regression. So random forest. So what is random forest? Random forest is a, so random forest is a learning method which is used for both regression and classifications. So basically, it builds what decision trees during training and combines their outputs for better accuracy and robustness. Okay, so where are the use cases? How can we use this? We can use this for predicting the sales based on multiple factors. So, and we can use this for classifying the customer churn in marketing data sets. And what is RMSE? So this RMSE is the root is a metric which is RMSE abbreviation is root mean squared error. and it is a metric used to evaluate the accuracy of regression models. So it measures the average deviation of predicted values from actual values in the same unit as the target variable, and r square is nothing but it is the coefficient of determination. So it measures how well the independent variable explain the variance in the dependent variable. So this is the rmsc r square and rmsc and r square which we got. And so these are the things we have done in our machine learning models. We have find out so much things, and time concerned, and as far as time is concerned, so I'm skipping out these things. These things are self understandable. Okay. Okay, once our data is our gold data is ready, so once our serving data is ready, we are going to need to write it in our gold container. We are using the same way to ensure the clean overwrite. Okay, now all the things are done. So I'll also show you my gold container. So this is my gold container. We have two files, which is predicted sales and another one is stock analysis. If you see our notebook, so we have two files. One is predicted sales. So we predicted a weekly sales based on our using our machine learning model. And so we have another file which is called as final stock analysis, which will have an extra column called current stock. We assumed our current stock as 500, and using that we predicted the remaining stock. Okay, so this is our final stock analysis, and we loaded the data into the gold sales, so according as I said earlier. And so now, from till now every step is completed, so till now most of the step is completed. And next thing which is pending is reporting. So reporting is nothing but we need to provide some visual insights. We need to provide some visual insights or statistical insights about the predictions we have made, about the what we have inferred, and we can do it in multiple ways. So our visualizations, you can use the display function of Databricks. If you output the using deep display, there will be option for visualization. You can use that, or if you can use this dashboards. What I have did is I have used the dashboard. And how I have did this is, so basically I have converted this final data frame into the delta table. Okay, basically, so I have created this delta table in the our Azure Databricks file system. So if you go to if I see here if you see here, if you go to catalog, we go into my workspace. If we go into default, you can find a table called final stock analysis. So this is how I created the default I created a table for our data frame. If I go inside this, so here you can see if you see the format, it is delta, and we have multiple columns. And using this I'm going to build my dashboard. How I have did this is by using the dashboard. So you can create your dashboard. So you can create it by a dashboard. You can use your data. So if you select a table, you can create your own table, or if you need select so as you see, we have already have a table. We can select this, and already have, so for time concern, already I have built my dashboard. Okay, so I'll show you my dashboard. So this is the dashboard which I have built already. I'll click into full screen mode. Okay, so this is my dashboard where I have done multiple things. I know it will be visually appealing for us. Okay. Okay, so first thing what I have did is I built a dashboard. So I built a, so these things are called widgets. Okay, so these things will update dynamically. How? So since we are running our notebooks at using our ADF pipeline, so it will be updated accordingly, and the delta table will be saved regularly, right? So once the data is saved regularly, this is like a widget. So in mobile phones we have widgets, right? It will be a interactive thing. So these things are interactive. So as far as the data is changed, accordingly it will update each records. Okay, so I have built the dashboard for weekly sales by stores, where you can see store number 4 as the most number of sales, which is 56.1 million. And I have to display sales by department in order to see which department sales records by each department. I have done this visualization. So yeah, I have done multiple things. So I monitored stock levels. I built a dashboard for stock management. So I have also built a dashboard for holiday sales analysis. It will say, so based on if it is false means it's a non-holiday day, and it is true means it is a holiday day, and you can clearly see that on a holiday day we have a more number of sales. But so if you notice this, the maximum number of sales in non-holiday day is 22.97 But if you see on a holiday day means it is 22.64K. What it says is maximum sales is more in non-holiday days, and the minimum sales, the number of minimum sales has been increased. So that's how it is for us. It is looking at the more sales has been done in holiday day. Okay, so you have also we built a dashboard for stock depletion rates, and so I have predicted, so I have built a scatter plot for weekly sales versus remaining stocks across each department. So the each stock will have a particular color. I have built this, and yeah, I have also built the dashboard for remaining stock by date, and I have also built some tables. Okay, so I have built some tables which will have the entire values, exact values, where which will the reporting team further will use. So you can use so if you click this three dots, there will be option. So since we are in full screen mode, I think it is not displaying. So once I go back to this, yeah, so once I go back to this, if you click this three screen, so you can download this as a CSV, which we can give it to our analyst team, where they can build more analysis. Okay, so this is how my dashboard will look like. And yeah, I have built a table for ranking of stores based on the stock reordering, and also I built a tables for shortages. So on a table for weekly sales, holiday sales impact, we have values for that, and I also built the table for sales, each sales by department. Okay, this is our reporting things. These are the visualizations and reports we have made. Okay. Okay, so now we have done the almost the 90% work. Okay, so we have build visualizations and everything. Okay, now our entire project is completed. So how is this the way it will happen in real world? If you ask me, no. So there is one slight change. Okay, so in an organization, we cannot update it manually. So let's say we have some. We have some data, we are correcting our notebook code. So once we correct it, we cannot save it, we cannot run it again and again manually. So in order to do that, there is a thing called DevOps. As the name says, DevOps is the thing, so where developers and operating team will be working collaboratively, where they can where they can implement continuous integration of the our project, and deploy it continuously. Okay, so if you go inside this, if you go inside my Azure DevOps, so if you click our organization, it will take you to a page. So you should need to create an organization. So if you go with the default organization, we can create our projects accordingly. So I have already created a project which is for our purpose, and so this is will be the default workspace of Azure DevOps. What is repos? So Azure boards, as I said, developers and operation team will be working on this. So we can here you boards is nothing but you can set your plans. We can set if we are working it agile. We can specify our sprints. We can basically it is like a plan where we'll plan more all the things. Repos is the thing we are going to work. So it is the repository. So this repository will contain all our code. Okay, so if, through how this repository will be connected to our Azure Databricks. Okay, from Databricks we are going to connect this repository with our Azure DevOps. How we gonna do this is, so if you see here, there will be, so once you create this project, if you go inside repo, there will be an option called clone. So if you copy this, and so if you go to your workspace, if you click any folder, let's say I am so I'm going into the users. Let's say I'm going this clone, need to clone this. If you specify this three dots, there is option called clone. Okay, so you can clone this accordingly. So let's say I want to clone, so if you go inside repo here, you also you can create this guild folder. Okay, so if you click this, if you click create folder, if you add for a URL, here you need to copy this what this Walmart's clone repository URL. So once if you copy this, uh, so once you copy and paste this, so it will automatically fetch the Git provider, and you can do this. There are multiple Git providers. Okay, it is Azure DevOps, GitHub. You can use for anything, and we are using Azure DevOps service. Okay, and we can specify the folder name, and we can create. Since I already created, I am not going to do this step. Okay, so you can clone this here. So whatever changes you make, let's say, so let's say I'm updating, doing some change. Once you clone this folder, I have already cloned this Walmart folder. Once you make any change, let's say I'm making some change here. Okay, I'm adding some rows and columns, so it will be updated here. So let's say, so it will be updated. So once you make a change and push our code into the main branch, so it will do the necessary changes. Let's say I will do it and show you. I'm adding some print statement. Let's say it is end. Okay, so I'm adding it. If you click this, there is already branch called feature. So I have created a branch called feature. So why we are not directly pushing into our main work, because this is a good practice. Okay, so we should not directly push our main branch. In the organizations, there will be multiple people who will be reviewing our code. Okay, so there will be a team lead who will be reviewing our code and approving our pull request. So we basically need to push our code into the separate branch. Okay, here I have created a feature branch, and I'm pushing my code there. So I need to give your commit message. Let's say I'm update, I'm giving my commit message as update, and if you commit and push, see there is a thing called message called, so it is successfully committed. So if you go inside this and refresh this folder, so as soon as the commit is done, you can see there is a notification for a pull request. Okay, whatever changes you push there, so there will be a request, there will be a request made here the team leader will approve this. So let's say it is asking for a title, we can give update. Okay, so team leader will review this and create a pull request. So where he can, where he will check this for reviews, and he will approve this. There will be multiple persons who are approving your code, and once you click complete, so see here, so here this is which this is called merge forward. And once you go see here, there is a thing called delete feature after merging. So it is a good practice. Once as soon as you uh, create a pull request, you should really delete the feature branch. Okay, it is a good practice, because there will be multiple persons who are working in the repo, right? There will be they will be creating some multiple branches, then it will be difficult to view. Okay, so once you complete the, so at each time, so you need to delete this features branch, right? So I am completing my merge, and if you see, it is running here, the merge pull request is completed. So this is how, if you go inside the repo and go inside this bronze folder, and if you see this at last line, so there will be, so where you uploaded, I think we have updated in gold file, right? In gold file, if you see this, there is a file there is, since it is in Python notebook, it is not displaying, but here it will be updated. Okay, so what we going to do is, so here we going to run a pipeline. So basically what this pipeline will do means, it will automatically run. So whenever a changes or code is pushed into the main branch, so pushed into the main branch, it will create a, so we will have a folder called release. Okay, I will show you that. so we have a folder called release. Okay, so we'll have a folder called release. So whatever changes made in this main branch, so it will take all the files from this our main branch, all this notebook code from our main branch, and it will automatically update to the release folder. And from that release folder, the pipeline, the ADF pipeline will run. Okay, how we, so to create the pipelines, if we go inside this, so you can create a new pipeline. So if you need a, so there is a thing called to create a new pipeline. We can do this in multiple ways. We can do it this using the UI, or using by writing the YAML code. What I prefer is by manually writing the YAML code. Why? Because it is more more controls in our hand. I like this way. Okay, we can specify multiple things. Okay, so we do this, we get a starter pipeline, so it will have a code. Okay, so for as far as now, I'm not going to create a pipeline. I have already did. I already did and show you that. Okay, I'll show you my YAML code and I will explain that. So basically, okay, so this is my YAML code. What is a pool? Okay, so it is like a engine which runs this code. Okay, it is the engine which runs the code. Okay, we have the group variables called a variable group called dev. Okay, so we need to create a variable group. Why? Because for this code, for using this, we are going to use Databricks, right? So we need to provide Databricks host and Databricks token, and these variables I have created inside my dev variable group. How can we create that? We can create that using, so if we go inside library, if you go inside library, just a second, it is loading. If you want to create a new variable group, you can click this and create. And as far as me, I have already created. I named this group variable group as dev. And inside this, see, you can add a variables by using this option. I have created two variables, which is Databricks host and Databricks token. How can you get this Databricks host? Databricks host is this is the let's say this is your URL. This is till this is your Databricks host. Okay, and Databricks token, you can get this from if you go inside settings, if you go inside developer options, you go into so you can see this option called access tokens. If you click manage, you can generate a new token. So if you click generate token, you can comment it, and if you generate, there will be token displaying. You can copy that, and it will be done once only. If you need another token, you need to create another generate another new token. So this is how I did. uh, so this is how I pasted my Databricks token and Databricks access key. Okay, so this YAML, what is YAML? You can ask. I forgot to tell. YAML is a scripting language which is used to create pipelines. Okay, this is not much a difficult language to learn. If you see, it is more human readable, human friendly. See, what we are going to do is, so we are going to create an artifact. Artifact is nothing but, so artifact is nothing. It is like grouping the entire things, grouping the entire things which is in the main folder and we main file, and we are putting this into the group called artifacts. If you see our pipeline, so once our pipeline is run, I'll show you the artifacts which is run. So it will take you into the Databricks CLI. So as you said, we have the Databricks token. So we gave this Databricks token already, and it will test that, and it will download the already available artifacts. Okay, and it will list that. And so once what we are going to do is, it will check the release folder. Okay, so it will check the release folder, it will go inside this, so it will see what are the already release available. It will delete that. So what are the release available, so it will delete those and create the new releases. So we have written the code in such a way. Okay, so it will delete all the old releases and deploy our new release. This is my YAML code. Okay, and if you see, so one as soon I, so there is a file called artifact ignore. So what this artifact ignore will do is, so it will ignore all the files, and it will include only the IPUI and B files. Why? Because if you see, there is many merge files. We have gold, we have so we have readme file, we have a YAML file. We don't need this in our release folder. We need only our notebooks, right? So to do this, I have written a artifact ignore which will ignore all the files except IPUI and B. Okay, so if I see our pipeline runs, so this is how a pipeline runs. As I said, there is a thing called artifacts, right? So if we go inside this, so if you see this artifacts, if you see there is one published, so this is what the artifacts is. If you see this is the artifacts. It will group the things which will be deployed into the release folder. Okay, so from this release folder, we are going to run our so if you go inside the release, so this release will updated dynamically according to our DevOps pipeline. From this release folder, we are going to run our notebooks. So I will go into the ADF, our data factory. Just a second, it is loading. So in this data factory, so we can run our pipeline. We can run our notebook pipeline using the notebook activity, and we can specify the notebook path accordingly. So I'll go to my pipeline. So Walmart pipeline is the thing which we created already. You can see I've already done this. I will explain this now. Okay. So basically there is an activity called, so if you search notebook, you can see this. You can drag and drop this here, and yeah, I have did this. And so if you see bronze notebook, again I named this. So you need to provide a linked service, okay, to your Databricks. And so in the settings you can specify the path. If you see, notice this, I have specified the release dot bronze folder, which is which you remember, it is the our DevOps, it will get, which is created from our DevOps pipeline. Okay, so this is how so it will automatically run. So while running, ensure the cluster is turned on, cluster is on, so it will run it will run soon. Okay, so if you go to silver notebook, and if you see silver, it is release folder, and gold, if you see gold, is also from release code. So this is how we have created the continuous integration and continuous deployment for our project. Let's say if I update the, so if I update my, if I go to my SQL DB, I add one more store. Okay, that one more store, so we have implemented pipeline in such a way it will run. So let's see, I have triggered this pipeline, already a trigger for this pipeline. Okay, so as I said earlier, trigger is nothing but it will for to run our pipeline accordingly. So in which time we want, we are setting it accordingly. So I have given the schedule trigger. Schedule trigger is nothing but it is there are multiple triggers. Schedule trigger is one of the type where you can schedule according to the time. Okay, I have set the trigger according to the 1:42 p.m. Okay, the start date is it is today 18/12/2024, and time zone is my time zone. And recurrence, as you said, I need this step, pipeline to run each one at one time every day. Okay, and I specified the end date too. End date is just day after tomorrow. And so yeah, this is how I triggered my pipeline. Okay, so what I'm saying was, so if we made any changes in our SQL DB, let's say we are adding one more store, so at the next day or the same day, the pipeline, when the pipeline runs, it will update it. Okay, let's say I am updating the code, I am updating some new code in my bronze notebook. What it will do, Azure DevOps will take care. Once a new code is updated and pushed to feature branch, and once we push to feature branch, it will be update, there will be a pull request created in Azure DevOps, and the pull request is if the pull request is accepted, and our YAML code will be, and our Azure pipeline will be triggered, and our YAML code will run, and on the, and in the release folder the file will be updated, and from that release folder our bronze notebook will run. This is how I have implemented continuous integration and continuous deployment. Now, if you see, come back to our solution architecture, you can see almost everything is completed. The only thing which is pending is it is security and governance part. Okay, so coming to the first one, which is key vaults. Key vaults. So what is key vaults? Key vaults is nothing but we can say like your store secret storage where you store all your credentials. So let's say, so for as you saw, as you seen earlier, so every time when you create linked service, we need to specify the storage account key, or if you use SQL authentication, you need to give your SQL server password. So to for those things, instead of directly specifying the real password there, you can encrypt this, and using a key vault you can give your you can create a secrets and give those secrets there. Okay, how you can do this is I created a key vault. So I named it to my name accordingly. So inside, if you go inside the secret keyword, I get, if you search for secrets, so there will be option called secrets, and you can create the secrets by clicking this. You can name it accordingly. Let's say you're creating for SQL server, you can give your password here, and if you save this, you can create this. So you can create this and use this at linked service. Yeah, so if you give your resource subscription, your keywords will be automatically displayed there, and what are the secrets available will be displayed there, and you can use there. Okay, so as far as now I have, so I already have multiple secrets. Let's say, so I'll show you that. So you can see I have multiple secrets. I have the access tokens for Databricks and secret SQL Server password, secret access code, username, and everything I have stored in my secrets. So this is how you can use this keyword. It is a good practice to use it. And coming to the Azure Active Directory, right? So Azure Active Directory. So why we need that? So think of in a scenario. Okay, let's say we are working in a, so think of so consider my situation itself. As I said, so I was working in a team, and my teammate is so I was working in a team. So let's say I have two team members. Okay, and we need to make sure that we are working on a same thing. So instead of using different accounts, instead of using different account, we can use the same account. How means, so as I said, we are using the same resource group, right? So the resource group will have these much file, these much services. Let's say this is my this resource group, and my resource group has these much services. Okay, and using this Azure Active Directory, what you can do this, so what you can do is, you can create a group. See, let's say I'm adding, so let's say you can create a group. Okay, so you can create a group by, so it's like more like creating a WhatsApp group. So you can name the group accordingly. Let's say in an organization there is a developer team. Let's say you are giving a name, and you can have a description, you can have a membership type, and you can select the owners. Most probably team leaders will be the owners of this group, and you can add the members. So if you add the members, they will have the access to our resource group. Okay, if they have the also access to the resource group, they can work on the same services which we are working. So this is how the work is integrated. Okay, it is a most recommended practice. So you can add a user here, so you can create a user or invite an external user here. Okay, so this is what is the use of Azure Active Directory. Okay, so we have covered the entire thing. This is what the end of our video. I hope I have given some insights at least. So I have brought some useful information to you. Thank you.